In this video, we'll learn about program memory. Now, the first thing that comes to your mind is what program are we talking about? So, we start with the .c program that we have. So, p.c, right? Then, the next step is we compile this program. We compile it to get a p.exe. Now this p.exe, then we run to produce the output, and when we run this program, it gets loaded in the RAM. It's an acronym. So this program gets loaded in the RAM. Now the structure of that allocation of the program into the RAM is what we'll be talking about in program memory. So let's focus on this program that we have here, the p.c program, and see how things proceed from here. So as we see, this is a simple program with a function main and a function add. So this is just a program to add two integers and produce the variable, produce the output. So let's first focus on the programs as such, the main and the add. So what happens when the program compiles? What happens to these functions, right? So let's first compile this program to proceed further and get an executable. So we compiled and compiled successfully, we get the executable. Now for the next step, we'll go step by step. So we can use this debug menu to see what is happening in the course of this program. So we can say, we can go to the debug tab at the bottom of the window here, press the run to cursor tab, and it will run to this level. Now at this point, what we can do is we can add watches. So to add watch, we can either use this tab here to add watch, or we can do a right click on this debug window. So we have three windows here, project, classes, and debug. So we go to the debug window and right click and click on this add watch, or you can just simply press F4. So let's see, so since we are talking about functions first, so we do have a few variables defined inside this function, a, b, sum, but let's first begin with function. So we have function main. So let's see what information we can get if we just type the function name here, main, and let's delete this variable. So function main, as we see here, we get some hexadecimal number on the right, 401290. So what this actually means is this is the starting address of the program into RAM. So this is where the operating system allocated memory for the program to get started, and main is the first function that any C program would start from, and that is the address at which the program gets loaded. Now let's see if we can get any information about add at this point. Now for add, we get another address, 4012EB. So we have 401290, and this is 4012EB. So it's basically 90 to EB. So EB is definitely a higher memory address. So what happens here? Let's see. Now let's try to understand what we are seeing here. So in this case, let's say we have a RAM memory bank that we are interested in, like defined like this. So what the operating system does when the program executes is it loads the function main into RAM. So this is main, and the starting address is given by 401290. 401290 in hex. Now the next function that we have is add. So add gets allocated some memory here, and the starting location for this is, as we can see on the left here, is 4012 EB. So it is 0x 4012 EB. Okay, and it will get allocated whatever memory it requires, right? So this memory allocation, as we can, so there are a couple of things that we should note here. Number one, the memory location where the program starts is given by main, and that is a lowest memory address, that is lower memory address between these two functions. Now this section in which the program memory gets allocated is called text or code segment. Okay, so text segment or code segment. So you can call it TS or CS in short. Okay, so and the thing to note here is the memory gets allocated in an increasing order. So what happens is, if we have more functions like add, let's say we wanted to have another function subtract that we would have called after this, then it would have added another more memory for that function subtract and kept on adding on top of this, and we would keep seeing the memory address of the start of this function increase. So this value here is actually pointer to this function, and this whole memory segment is called text segment or code segment. Now next what we will do is we'll see what happens to these variables. So let's divide it in a separate session, next video, so that things are kind of clear. So in this video we basically learned about the text segment or the code segment. Text segment, actually let's use this, text slash code segment. Alright, so that's what we will read here. So let's go to the next video for what happens to the variables.